And these two examples of inverse trig functions, they're going to be a little bit more challenging than part one was. We have this inverse tangent of this fraction, but there's a 2 on it. That's what's going to throw that thing off. And then on this one, we don't have a numbers, we have a letter. So both of them are definitely going to be a little bit of a notch up from what the prior two problems were. But just a quick refresher, we're talking about inverse slash arc, sines, cosines, and tangents, so it limits us to where we can talk about angles, and the inside is just helping us draw our picture. That's all that's doing. So this piece is going to build our picture. Okay, so and then we'll have to deal with the fact that that's a 2. So this is our picture, and we're doing inverse tangent, that's positive, so we're only narrowed down to these two quadrants, so we're talking about just the first quadrant, and that is theta. So actually this whole piece helps us figure out theta. We're not actually going to figure out what the angle measurement is, but that's the idea, that an inverse is always going to give us an angle measurement. But in our case, it's just helping us draw our picture. So we have opposite over hypotenuse, 12, 5. So we can do Pythagorean theorem to figure this out, or if you remember, this is a 5, 12, 13 special right triangle. So once we have that, let me kind of rewrite where we're at, because it's a little more complicated than just doing sine of theta. So it's not just 12 over 13, because really we're sitting with sine of 2 theta is really what we're sitting with. So that 2 definitely comes in and plays a role. Well, 2 theta is a double angle identity, and that is 2 sine theta cosine theta. So really we're going to rewrite that as this, and that's our theta that we have from our picture. So it's just going to become 2 times sine of theta, which is 12 over 13, and cosine of theta is 5 over 13. And then at the end of this, it doesn't matter whether we have a double or a half or anything in there, this value that we get out of this, our output, is not going to be anything bigger or smaller than, it's going to range between a -1 and a +1. So we have 10 times 12 is 120, and 13 and 13 is 169. So we'll try and simplify that down. So 120, we can take a 3 out of both of those. So that's going to get us, never mind. 169 only consists of 13 and 13, so we're not going to be able to break it down. So that's going to give us back to our 120 over 169. We can't simplify. Okay, so this one. So again, same thing. This is going to help us figure out our triangle, but we have a letter on here. So what I'm going to do, because cosine is adjacent over hypotenuse, I'm going to make it a fraction. So when I build my picture, we're drawing it in the first quadrant, and we have, let's see, adjacent over hypotenuse. So our hypotenuse is 1, our adjacent is u. And if we do Pythagorean theorem here, we're looking at a y value, let's call that, of u squared plus y squared equals 1 squared. So if we would subtract the u over, we would have y squared would equal 1 minus u squared. So 1 squared is 1. And then we would have to square root that. So y would equal the square root of 1 minus u squared. And that is our measurement to that side. So that is done. That gives us our angle. And so now we're doing sine of theta. Sine of theta is going to be this weird side of 1 minus u squared, square rooted, divided by hypotenuse, which is just a 1. So really, we're just getting 1 minus u squared. So it's really just kind of turns into a formula. But that's it. And that is a little bit more challenging versions of evaluating inverse functions.